All right, seventh grade, there were a few questions. So specifically, we had, let's see here, we had 7-34B, we had 37, and 38D and E. I know the question came up about the stem and leaf plot. I don't remember which problem that was, so I'll just write it down. So we've got 34, 37, 38, stem and leaf, and then get through that and then help any of the 8th graders that showed up. There's probably none because, 8th graders.
The wave plot is like 738, like 8.
Cool. All of it, yeah. All right, that's easy enough. Okay, so let me go into here. We had 34B. Okay. Yeah, these ones are worth going over, especially because I've noticed a few things on a couple of homeworks that I want to, fix. So on these ones, like 7-34, I'll start by looking at part B. The first thing you want to do is you are going to identify the like terms. And in this case, I'm going to go ahead and I'm going to do this with a highlighter. So like negative 8x is a like term to a positive 10x. And I want you to notice that I am including the symbols with it because you always need to include the symbols there. And then whenever I combine those, like negative 8x and positive 10x, together some of them cancel out. And so you're left with just a positive 2x. Okay, and you don't have to write plus in front of the 2. You can just write a 2x because you can start with that. So in this case, you're just doing 10 minus 8 and then getting that one. And then if you're looking for your other like terms, you look at positive 4. And I know there's a plus negative, so just call this a negative 3. It's going to work the same way. So positive 4 and negative 3 together make what?
Positive 1.
Yep. Your answer is just 2x plus 1.
See, I thought the negative 8x plus the 10x is like 10 plus 8.
It's, you could think of it a few ways. You could think of it as negative 8 plus 10 or 10 minus 8. But either way, you're going to get 2x. Okay? You could put them in either direction, but as long as you get a positive 2, you're fine. One thing that I want to point out is I saw this on somebody's homework. If you have stuff like this, you can't ever combine the x squared with the x's. Those are not like terms just because they have an x. So like if I marked all of the like terms, like the negative 4 and the positive 4 are the like terms here. So those two make 0, which, you don't have to write 0, obviously. And then the 1x squared cannot combine with anything. And then the positive 3x can't combine with anything. So that's your answer. Don't do anything like 4x to the third or 4x squared or 4x to the fourth or anything like that. You can't add these together. It's like saying if I have 1 apple plus 2 lemons, or 3 lemons, whatever that number was, you don't all of a sudden have 4 something. It doesn't work. You can't have 4 apple lemons. You can't combine those things. So that's all you do for that one. 37. Which part of 37? Because that's a lot, and I'm lazy. I mean, no, it's a lot, and you have calculators. Which part of 37 is particularly, is more of the challenging one?
I need help on D and F.
Oh, look, fractions. Okay. It was your question, so unless anybody else speaks out against D and F as my 2 to go over, I'll go over those. Don't ask for help on E. I mean, you could, but... Okay, So I know that this one's awful for a couple of reasons. First of all, there's all of these extra symbols here, but there's also extra parentheses and it's all fractions. So what I'd like to suggest doing is that anytime you see a plus and a minus together like that, you just call it a minus sign. So I'm going to keep negative 7 over 10. This is now just a minus 5 over 12. And then the minus parentheses is just a minus 1/4. Okay. So in order to make this a little bit cleaner, the first thing that I did was I just dropped all the parentheses off, which you can do if you are careful about it. Okay, the only thing to be cautious of is if this was like a negative 5 over 12, then when you rewrite it, it's a positive 5 over 12. So just keep that in mind. If it were negative, that's when something weird happens, but it wasn't, so we're okay. So step 1 is to just kind of make it look better. Step 2 is to do a common denominator.
So wouldn't that be 60?
Mm-hmm. And yeah, in this case it is 60. So if you're not sure how to find that, you can start testing. You can be like, well, okay, you know that 4 goes into 12, so you can pretty much ignore the 4 for now and just use the 12 and the 10. Because if 4 goes into 12, anything that 12 goes into, 4 will also go into that. So you can just forget about dealing with the 4 and only look at 10 and 12. So if you counted 10, 20, 30, 40, 50, 60, and then you did by 12s, you just go until you hit a whole number. 48 and then 60. And as soon as you hit that same number, you know that your target common denominator is supposed to be 60 for these. Or you look at a times table, or worst case, you just know that 10 times 12 is 120 and just use 120. Like worst case scenario, you just use the biggest the big number, which is just a multiple of those two. So here I need to change this fraction into being out of 60 minus something out of 60 minus something out of 60. And so you figure out, okay, well, I times this one by 6 over 6. I'm going to times this one by 5 over 5. And I'm going to times this one by 50.
Yeah.
Okay. Yeah. So then this one, 6 and 7 is 42. 5 and 5 is 25. 1 and 15 is 15. And because they're all negative, the easiest way to do all the negatives together is to just add them together and then keep it negative. Because it's 3 negatives altogether. So whatever my answer is going to be a really big negative number. So 42, 25, and 15. And I'm just adding them up because that's the shortcut for negatives. Or you could just do negative 42 minus 25 minus 15. 40, 50, 60, 70.
Negative 82 over 60?
Yep.
Oh my. Okay.
Yep, negative 82 over 60. That will reduce for sure by even numbers because they're both even for sure. So you can divide by 2 and make that 41 over 30 is probably the lowest that's going to go with a negative in front of it. So negative 41 over 30 is the simplest that'll get.
So are you wanting us to reduce as much as we can?
Yes. So reducing it, yes. So reducing it is good, yes. Reducing it's good. You don't have to write it as negative 1 and 11/30ths. Like, you don't have to do that. Or if you had this one, you don't have to go negative 1 and 22 over 60. Like, I don't like those as much. I would very much prefer you to leave it in this improper fraction form. F is going to be really similar then. So the only thing is to mention the minus minus that I talked about means that that's now a plus. So then you've got your 7/8 plus 1/10, and then this plus minus is now a minus 3 over 5. Okay. And so then you look into your common multiple between 8, 5, and 10. Again, 5 will go into 10, so anything that works for 10 and 8 is going to work for 5. So you're going to want to use 40. Because you're thinking, okay, well, I need 5, 10, and I need 8. Well, okay, I know 5 goes into 10, so let's just forget about using 5. and then just go, oh, okay, I know 8 goes into 40, so 8 and 40 is the way to go. So same idea. I need to change all of these to be out of 40. Okay, and so then you're like, okay, well, I need to times this one by 5 over 5. I need to times this one by 4 over 4. And that one by 8 over 8. And if you do all of that, you're going to have 35, 4, and 24. So you add the positive numbers to get 39 over 40 minus the 24 over 40. Again, if you have something like 15 over 40, 5 goes into both of those really easily. So if I do that, I get 3 out of 8 as my answer. So it's just kind of one of those, just be careful and recognize the common denominators and then go through there on those. Okay. 38. This, oh, you guys just skipped this because it was an entire page. Feeling like you just skipped this because it was an entire page. Is that right?
No, I need help on 738. Because I don't really know how to find the weight of a player.
Okay. Wait. Sorry. Can you clarify what you said? It's a little bit loud.
I need help on 738.
Yeah.
Because I don't understand how do you find the weight of a player.
Oh, the typical weight of a player. Okay. That's, yeah, that makes sense. So let me put all of this here so that we can do this. Okay, so if ever you are like starting these off, right? If ever you're starting these problems off, the very, very first thing you should always do is to arrange them from smallest to greatest. Okay, so like if ever you've got a bunch of data like this and you're trying to do it, so even before you start stem and leaf or start histogram for them, you're going to want to you're going to want to rearrange these from least to greatest. So because I'm going to do all of the work based off of that information. So the smallest weight on this team is 106. Okay. And then you just start counting up and getting the next information in order. And if I forget one, please let me know because I'm trying to do this on the fly. So then 115. And then the next highest is 120. And another 120. So you write both of them down even though there's the same weight. And then 122. 126. 130. 133, 147, or sorry, 142, and then 147. Okay. So after you've arranged all of these, the first question is, what is a stem and leaf plot? Okay, the what is a stem and leaf plot is one that I don't know if you guys have done these before.
We did them a little bit.
Yeah. Yeah, and they probably show up a little bit in science as well. I don't know if you guys did these in science. So essentially, yeah, a stem and leaf plot is a way to write all of these numbers in a very confined way. So if I took 106, for example, the 10 would be my stem, and my leaf would be 6. And I know there's like, okay, well, why would I split it up that way? It's because if I wanted to do 112, the 11 is my stem with a leaf of 2, but then I can put 115 here by just putting a 5 there. Because putting the 5 there is the same as putting 11 and then a 5 right there. That's where that's coming from. Okay, and what it's going to do is it's going to give me a way to write, so all of my stuff in the 120 range, I start my stem of 12, and then there are 2 zeros for 120 and 120. then there's a 2, and then there's a 6 for the 122 and the 126. Do you guys kind of see where those came from?
Yeah.
Okay. And then those two are the 13s or the 130s. So 13 with a 0 and then 13 with a 3. And then the last two are 42 and 47. So it's 142 and 147. And so you put all of those in your stem and leaf plot. Now, if you're just looking at this, right, this is your stem and leaf plot of the player's weights. Okay? Any questions on how to come up with that one for you guys?
No.
Okay. Somebody's home shopping. A histogram then is essentially just a bar graph. Okay, so this is your histogram. Okay. And what you do is you sort it into basically the same groups that you did for the other ones. So this first one would be anything from 100 to 109. And then the next one would be 110 up through 119. Sorry, let me make that a little bit bigger. So 110 through 119. And then you go up to the next step. You go 120 to 129. And you can honestly split these up however you really see fit to do, or whatever you think is the best way to do this. But in general, because you're using a stem and leaf where it's by tens, it makes sense to just go by tens for the same amount on the other side. So then this is going to get kind of tiny and can't really read it. So this is the 130 to 139. And then the last section is 140 to 149. And all that this is it's just going to give you a count of how many numbers are in this spot. So there's 1, 2, 3, 4. So I'll just put that there. So in the 100 to 109 range, you can just look right here on the stem and leaf. There's exactly one number in that range, so I put a bar graph that is 1 unit tall. Okay. In the 110 to 119 range, right, if I'm looking at the 110 to 119, I look at anything from 100 and whatever up there. So now there's 2 of these answers. So I'll switch colors here. So there's 2 of these. Okay. And you can shade these in however you'd like. And then you look at the next spot, which is the 120s. There's 4 points of data in there. So your bar graph is going to go all the way up to 4. Okay. And then similarly, the 130s have 2 because there's 2 numbers in there. And then in the last part, there is only 2 numbers there. So that bar is the same height. Okay. So I know that all of this is like, okay, well, your question was on the last part of this, but actually getting the stem and leaf in set up helps you answer the rest of it pretty easily. I know that this is kind of hard to read, but it says describe the shape and spread of the data. Okay, the shape and the spread of the data. So what that means is if you looked at this, there's a few different types of spread, which is usually like evenly distributed or normally distributed, or symmetric is the big one. It says symmetric is what you want to look at, because in this case, this data is pretty much the same on both sides, and it kind of comes to a peak in the center. It's going to show this idea of what you'll eventually learn is called a normal curve, where like your data flows to a large point in the center and then it tapers off at the edges. So that's an idea of a normal curve. So the idea is that it is symmetric. Does it have more than one peak or only one? It is single peaked because this goes up to a single high point and then the rest of it tapers off. Is it tightly packed together or widely spread out? That's kind of a little bit harder to say. I would say that it is spread out because it goes all the way from 106 to 147, but that's really up to interpretation. Like saying it's spread out is kind of a iffy one. I would say that this one is, I don't know, it's hard to say. I'd probably say tightly packed together now that I think about it, because there's a whole bunch of points in this area. That's where most of the data is in the 112 to 133. That's kind of all in the same spot. Does it have any outliers? So what is an outlier according to the data? Like what would normally an outlier be? What would you guys count an outlier as? Any of you? What's an outlier? Or do we not know? Just you can unmute and say you don't know, so I know I'm not just talking to an empty room of 4 computers in 4 different homes where nobody's there.
Well, isn't it like the value of the outside?
So close. It's a point of data that doesn't fit with the rest of your data. So like it's something that's really weird. So like if, for example, you had these weights of all of these students and then you had something like this. So you've got like 106, 112, 115. You've got all of these in like the nice normal numbers, and all of a sudden you've got 235 or something absurd, like way out of the norm. Or even like 52 or something crazy, right? It's something that's very far away from the normal. So no, there's no outliers. And if there's no weird points of data, then when you calculate this, you want to use the median to find the normal amount, okay? And I know that that's not something that we've really covered at all or talked about, but the idea is and you've had a few homework questions about this, if you are calculating an average of your homework or assignments or whatever, an outlier will change the average a lot. Okay, an outlier is going to change the average by a ton, but if there's no outliers, then it's fine. Okay, if there's no outliers, then it's fine to use the average. And I'm dumb. I shouldn't have said median there. I'm sorry. You should use the average for these because there's no outliers. I was saying something and then wrote something different. So in this case, you could use mean or median, but mean is probably going to be a little bit better. And then you say, to describe the typical weight, you just say, oh, I'm going to use the mean because there's no outliers. So this, I could actually just write here, use the mean if no outliers. Okay. And then you could say typical weight of the player is to actually just take that mean or average. Okay, actually just take that average of these numbers. And if you forget how to do average, you add up all the numbers. So you do the total weight divided by, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 people. So you add them all up and then divide by 11. And then in order to find the range of data, the range is just your range. You could think of it as the high value to the low value.
Isn't the range 41?
Yes. Yeah, it's 41 because you do 147 minus 106. And you just get 41 for that, 41 pounds. Or whatever units they were using, I don't actually know. Yeah, pounds. So if you're doing range, it's just the highest to the lowest. So you do like the 147 minus the 106 to find out how far spread apart those are. And the reason why this outlier will change things is, let me give you an example based off of something that I just sort of heard. Who in the background is listening to stuff about houses? Or who in their back? I heard somebody in the background talking about houses and properties and stuff. Is one of you guys looking to move or buy a house or something? Was that you, Araya? Were your parents talking about houses and stuff?
That could have been me.
Okay, great. Um, so like, let's just say, for example, I'm going to give you guys just a really bare bones example. Give me 1 second to come up with it. Okay, what if I told you that the average price of a home in this place, right, is 185,000. So I'll just put a K there for 1,000. Okay, and you're like, okay, well that tells me something about the neighborhood, right? But then if I say like, oh, so the normal houses in the area should cost $185,000, makes sense. But then what if I tell you that the points that I used to calculate that look like this? What if your numbers were 120, 130, 140, 120, 150, and 450? So these are the 6 numbers that you found the average of, and your data says, hey guys, the average of all of these houses is 185,000. Does that tell you what most of the houses are like in this range? Like, does that tell you the value of most houses or not based off of these 6 points of data?
Not really.
Why? Why is it weird? Why does that not make sense?
Well, because there's like over 100,000, and then there's one that's 450,000.
Yeah, so like if I listed all of these points in order, right? 120, 120, 130, 140, 150. Okay, and then 450, right? So if I looked at those and I said, hey, based off of this number, most of the houses in the area are $185,000. The average cost of the houses is $185,000. That might be
Testing 6 of the houses in the whole area, so that wouldn't be very accurate.
yeah, so you could even say, so let's just say, you're right, Allie, that's right, you need more points of data. Let's just say this is a 6-house little cul-de-sac area, like it's a nice little block, right? And your neighbors or you're trying to sell your home and you're like, well, the average house in this area is $185,000. You should totally move here. But that doesn't account for the fact that this is a super high dollar house and the other ones are all kind of like really low end, right? So it wouldn't be every house is 185,000 like at the higher end or medium end. It's most houses are in this 120 to 150 range, and then there's this super rich person fancy mansion on the corner, right? Does that make sense why it could really throw off the numbers here?
Yeah.
Okay, so that's why average or mean doesn't like outliers. So don't use outliers when you're doing that. You would want to use a median value. Okay, so the median value would be to look in and you count inward. So like 1 1 1 1 1 1. The middle value of this is 135,000. Okay, now based off of this data, that's the much more likely answer is that, oh yeah, if you just pick a house, it's probably in the 135 range. So it helps when somebody's shopping for a neighborhood to not just look at average prices, because these rich mansions can throw it off. Like, you wouldn't look at the average of 3-bedroom home, 3-bedroom home, 3-bedroom home, 2-bedroom home, 4-bedroom home, 8 bedrooms and a master jacuzzi and marble columns and, right, 3-car garage. Like, if you're looking at all the homes, you're not going to be like, oh yeah, I'm just going to pick one of these and, oh yeah, let's just throw this one into the calculations. You wouldn't do that. You would look at just the ones that you're focusing on. So that's kind of why you don't use the median and the mean. You have to choose which one's better. Okay. Do you guys like that I changed my little tag over there for the office hours? Did you guys see that on the screen that I changed my tag there for the lack of 8th graders in office hours?